In this video, we're going to review some geometry properties about angle relations. So, we're going to start with vertical angles. Vertical angles occur when we have two lines which intersect. So like in this case, we have QP and NR intersecting at the point M. Right? When they intersect, angles on the opposite side of that intersection point, so in this case, RMQ and NMP are what we call vertical angles. Now, vertical angles by geometry have equal measure. So this angle right here and this angle right here are exactly the same, which is why I use the same line right here to denote that they are equal to each other. Okay? Now, this angle on this side is not the same necessarily, okay? But it is vertical to this angle over here on this side. Okay? So I'm going to use two lines to denote that these two angles are the same, and one line, these two angles are the same. Again, these are called vertical angles, as well as these are vertical angles. Alright, our next piece of notation is about a transversal. So a transversal is a line which crosses two parallel lines. So these lines, M and N, are parallel, they don't intersect. And then a transversal would be this line right here. Okay, so we'll call this a transversal, say T. Alright, now when you have a transversal, again, crossing two parallel lines, then we're going to get all kinds of angles that are equal to each other. Like, for example, this angle and this angle are vertical angles, so they're equal to each other. And this angle right here and here are vertical angles, so they're equal to each other. Alright, so we have a lot of other relations. So, for example, alternate interior angles have equal measure. So if you're like, what is an alternate interior angle? Just break the word down. Interior means you're on the inside. So we're on the inside of the parallel lines. And then alternate means on opposite sides. So we're on the inside of the parallel lines, and on opposite sides are alternate sides of the transversal. So this and this are alternate interior angles, and again, they're equal to each other. And this and this are alternate interior, and again, I use double lines to indicate that they're different angles, but these two things are equal to each other. Alright. The next one are alternate exterior angles have equal measure. So again, just break it down. Alternate means on either side of the transversal. Exterior means outside of the parallel lines. So outside the parallel line, say this one, okay, and then opposite side of the transversal, alternate, so over here. So right there. So those are alternate interior angles, and again, they're equal to each other. Okay. We also have these right here as alternate interior angles. Again, notice the double lines there. Alright, corresponding angles have equal measure. So corresponding angles are angles which are either, like, say, both on top of your parallel lines, like this, on the same side of your transversal. So these are corresponding angles. Okay. Also, these would be corresponding angles right here. Okay. Again, they're on the same side of your parallel lines below them, right, and the same side of your transversal, say to the right. Right. And then we actually have four total. I'll draw one more right here, again, above your parallel lines on the left of your transversal. So these are equal to each other. Okay. And these are also, but I don't want to draw four lines. I'll just get a little bit messy there. Okay. Alright. Interior angles on the same side of a transversal are supplements. So, for example, this angle, let's say A, and this angle, B, aren't the same, okay? But they're interior angles on the same side of the transversal. Interior, again, means inside of your parallel lines. Same side of the transversal, that's pretty obvious. Again, these aren't equal to each other. You can see one's acute and one's obtuse, so they couldn't be equal to each other. But they are supplements. A plus B, and if you remember what supplements means, it means that it adds up to 180 degrees. Right? Alright, and you might have actually proved a fact like that if you took a geometry course like before. Alright, let's try some problems. So, let's find the measure of all these angles drawn in this picture. 1, 2, 3, and 4. Right. So, the way that we want to approach this is we want to start with the angles that they actually give us some information about, namely 2 and 3. Right. So 2 and 3, right, are interior angles on the same side of the transversals. Okay. So they must add up to 180 degrees. So Whoops. So 2 plus 3, okay, is equal to 180 degrees. And I'm talking about angle 2 and angle 3, not the numbers 2 and 3. Okay? So that means that 9x plus 9 degrees plus 7x minus 5 degrees, okay, is equal to 180 degrees. Okay, so let me circle these so you know that those aren't actual numbers, those are angles. All right. So now we just do a little bit of algebra here. 9x plus 7x is 16x. Okay. 9 minus 5, just combining my terms, is plus 4 degrees. Is equal to 180 degrees. Okay. So isolating our x's, we get 16x is equal to 176 degrees, just subtracting 4 from both sides. And divided by 16, we're going to get x is equal to 11 degrees. All right, so that's not the answer, that's just what x is. So now we know that, let's label it this way, angle 2, okay, is 9 times 11 plus 9, okay, which is equal to 108. Okay. And angle 3 is 7 times 11 plus 9, okay, which is 80, or sorry, minus 5. So that doesn't work. So 7 times 11 minus 5 is 72 degrees. And again, these are supplements. If you add them together, it gets up to 180. Okay, so that gives us 2 of our angles. And then we have to use our other geometrical facts to figure out angle 1 and 2. So angle 1 and 2, okay, those are vertical angles, so they're equal to each other. So angle 1 is equal to angle 2. So angle 1 is also 108 degrees. Okay. And angle 1 and 4 are equal to each other, or angle 2 and 4 are equal to each other. Angle 1 and 4 are alternate exterior angles. Angle 2 and 4 are corresponding angles. Either way, angle 4 is equal to angle 1, so it's also equal to 108 degrees. Okay, so again, we got angle 1 to be 108, angle 4 to be 108, angle 2 to be 108, and angle 3 to be 72. All right, let's try one more. All right, and if you want to, you can try to pause the video and then try this problem yourself, and then replay the video when you're done and see if you got the correct solution. All right, so let's look at this. Again, what we want to do is start with the 2 angles, which they tell you something about. So angle 1 and 2, they give us some stuff about x's, and they're alternate exterior angles. So angle 1 is equal to angle 2. Okay? So 2x plus 61 is equal to 6x minus 51. And we just want to solve this algebraic equation. So we want to isolate our x's. Say subtract all our x's over to this side. We get 4x. And add all our degrees over to the other side, which we'll get 112. Okay? Divide both sides by 4. All right. And we'll get x is equal to 28 degrees. Okay. All right, so if x is equal to 28 degrees, then we know that angle 1 and angle 2, they're equal to each other, is equal to 2 times 28 plus 61. Okay? Or you could do 6 times 28 minus 51. Either way, you should get the same number here. And when we do the arithmetic on our calculator, we get 117 degrees. Okay. All right. Now, this is also equal to what angle 4 is equal to. Okay. And if you think about that, again, you can think about it as being vertical angles. 2 and 4 are vertical, so they're equal to each other. Right? So 1, 2, and 4 are all 117 degrees. Okay. Now, 3 is supplementary to 1, okay, or it's supplementary to 4 because it makes this straight line right here. So angle 3 plus angle 4 is equal to 180 degrees. Right. And again, we know that angle 4 is 117. Okay. So this tells us that angle 3 is equal to 180 minus 117, or 63 degrees. Okay. So we found all of our measurements. All right. Next. So you might know this theorem from, again, like a high school geometry class, or probably even earlier than that. But it is a theorem that says that the sum of the angles of any triangle is 180 degrees. Right? So in this problem, we want to find this missing angle x. Okay? And we're just going to use the above theorem to do that. Right? So again, if we add all these angles up in this triangle, we're going to get 180. So if we take x plus 30, okay, and remember that this little square symbol here means that that's a right angle, or 90 degrees. So x plus 30 plus 90 has to equal to 180. Okay? Or x plus 30, if we solve this slowly, we're going to get x plus 30 is equal to 90, just subtracting 90 over. Okay? Which means x and 30 are complements of each other. And just subtracting the 30, we get x is equal to 60 degrees. Right? So it's a nice fact to know that if we do have a right triangle, the other two acute angles in there have to be complements, which is why I did this slowly like this. You might have just subtracted all these numbers over at once, but I want to do it slowly just to show you that those two acute angles in the right triangle are complements. Okay. All right, so some different types of triangles. Again, this is terminology that you've probably seen before, okay, but that's okay. So first we have acute angle, or acute triangles. So acute triangle is a triangle where all the angles are acute. And again, acute means that they're all less than 90 degrees. Okay, and positive, so you don't have negative angles in a triangle. So all these angles in here are less than 90. In fact, they all look around 60 degrees. Okay. A right triangle, it has a triangle which has one right angle. And again, here's the notation for a right triangle. Again, a squared off symbol right here. Right. And then an obtuse triangle. Obtuse triangle has one obtuse angle. Again, an obtuse angle is an angle which is bigger than 90 degrees. So that's our one obtuse angle right there. All right. Some more special triangles. An equilateral triangle is a triangle where all the sides, and then that's going to make all the angles as well, are equal. Okay? So to denote that, what we did was put lines through here, and that they're all the same, so we've just put one dash through all of them. Okay? And if you remember, equilateral triangles also have all the same angles. In order for them to all be the same and add up to 180, they all have to be 60 degrees. Okay? All right. An isosceles triangle is a triangle where two sides are equal. So, for example, these two sides are equal. This side is different. Okay, so again, we use one dash, and that denotes that these two sides are the same length. This side is a different length. Okay? And then these two angles, the ones opposite of the same sides, are equal to each other, whereas this angle might be different. Okay? All right. A scalene is a triangle which no sides are equal. So this side, and this side all have different measurements. So I use a different amount of dashes in each one to denote that. All right. Another definition that we're going to use in this class quite a bit is similar triangles. Similar triangles have the same shape, but not necessarily the same size. So for example, these two triangles are in the same ratios of each other. They're the same shape. Okay? They're both right. Okay? This angle matches up to this angle. And this angle matches up to this angle, but they're different sizes. Okay? On the other hand, congruent triangles have the same size and shape. Okay? So they're exactly the same in every way. Okay? So the way that this works is that if you have two triangles which are congruent, they automatically have to be similar because they have to have the same size. But if two triangles are similar, like these two, okay, the one in my picture, they might not be congruent. Okay? Like these are different sizes, so they aren't congruent to each other. But again, they are the same shape, so they're congruent. They're similar. All right. So the thought that we're going to use quite a bit about similar triangles is that similar triangles, or two triangles, are similar if and only if corresponding angles have the same measure, right? And the ratios between corresponding sides must be equal. Right? So let's try an example using the first part of this. So let A, B, and C, or ABC and DEF, these two triangles, be similar. We want to find the measures of all the missing angles. So for example here, in the first triangle, we have B is equal to 80 degrees, C is equal to 30 degrees, and we don't know what A is. Right? But remember that A plus B plus C has to add up to 180 degrees. So we can solve this just by subtracting both these numbers over, and we get A is 70 degrees. Okay. All right, if we look in the other triangle, okay, again, since they're similar, corresponding angles have to have the same measure. So A and D have to be the same. So D and A are the same. And A we already figured out is 70 degrees. Okay. E is in the same position as B, but we already labeled that as 80 degrees. And F is in the same position as C. So F is the same as C, or 30 degrees. Okay. So we found all of our missing angles. Alright, now the one that we actually use a little bit more is number 2. The ratios of corresponding sides must be equal. You do this in all kinds of different problems in math. So let's look at an example of that. Okay. So in this example, we have A, B, C, and D, E, F are similar triangles, and we want to find all the missing lengths. Okay. So we have all the information for A, B, C, and now we want to find D, E, F. Okay. Alright, so let's look at this. So again, the ratios aren't similar or are equal to each other. So for example, if I do DE, that side, over 20, okay, it should be in the same ratio of the same two sides, or the corresponding sides, on the other similar triangle. So in the same place as DE is AB, okay? And the same place as DF, 20, is AC, or 10. Okay? So again, this is from AB, and this is from AC. Again, they're in the same positions as in their similar triangle. Okay? So we can solve this. DE is equal to 20 times 8/10, just doing a little cross multiplication there, or we get DE is equal to 16. Okay, so now we know what DE is. All right, so our last side is FE, okay, and we do the same thing. We do a ratio. FE over a known side, so FE, say, over 20, is in the same proportion as the same two sides on the other triangle. So on the same side as FE is CB, 12. Right? And the same position as the 20 over here is this 10 over here. 10. Okay. Alright, so now again we can solve. This says that FE is equal to 20 times 12/10, or 24. So we know FE is 24 and DE is 16. Alright. One last problem. So this also has to do with similar triangles, but it's in a word problem. Alright. So let's read the problem. So we got a word problem. First thing you want to do is just read it. So Joe wants to find the height of a tree. The tree casts a 38-foot long shadow. At the time Joe, who is 5 feet tall, casts a 40-inch shadow. Find the height of the tree. Okay. So this question is asking about the height of the tree. Alright, so typically in algebra problems or trig word problems, what we want to do is first read it, find the actual question being asked, which I underlined here. Okay. The next thing is to draw a picture if possible. So in this case, a picture would make sense. So we have a tree. You don't have to be a great artist. Okay. I'm not a great artist, so we have a tree. Okay. And this tree, we don't know what its height is. That's what we're trying to figure out. So I'm going to label that with a variable. Okay, say h. All right. And what happens for a shadow is that the sun comes down, casts a shadow off the top of the tree, okay, and the length of the shadow is over here. And it says that this length is 38 feet. Okay? Now, if it's at the same time of day, which is what this says, then we should get a similar triangle because the sun is at the same exact angle. Okay? So these two triangles should be similar. Right? Now, Joe is 5 feet tall, and now his shadow is 40 inches. Okay? Alright, so these should be in the same proportion. So we should get something like h over 38 is in the same proportion as 5 feet over 40 inches. Now, in order to make this work, we need to get the units to be the same. Okay? So this is a problem that we have feet and inches here. Okay? So we need to get everything into the same units. So what we need to do is convert 5 feet into inches or 40 inches into feet. I'm going to do it into inches. So 5 times 12 is 60 inches over 40 inches here. All right, and you might be concerned that the feet over here and inches are different, but it just has to be the same on the same ratio because these inches are actually going to cancel with each other. Okay? And now this is a pretty easy equation to solve. H is equal to 60 over 40 times the 38 feet. Again, our units were the same, so they canceled for the inches, and we're going to be left with feet as our units. Right? So our height is going to be 60 divided by 40 times 38, or the tree is 57 feet tall. Okay. Alright, so that concludes this video on some angle relations. Okay. Again, after you watch this video, you should go ahead and try the homework for this section. Thank you for watching and paying attention.